Last year, we had a great discussion on LCP and images. But as Core Web Vitals continue to mature, one thing remains. LCP issues are largely driven by image loading at a rate of about 75% on mobile and 80% on desktop. Fixing this is investigative work, and there's no better magnifying glass than WebPageTest. So, here to talk about how to leverage WebPageTest to look into image-related LCP issues is our good friend, Tim Kadlek. Enjoy.
All right. Thanks. Yeah, I was looking forward to this. I wore the bright shirt so that it would be easier for you to spot me on the thing. Funny thing is, almost all of my shirts are black or gray or dark brown or blue or something like that. So literally every time I put on this shirt and walk out of the room, the kids all like stare at me and they're like, "Dad, you're wearing yellow," and everybody freaks out. So they're actually a little unsettling. Anyway, I wanted to talk today about images, and specifically images as they pertain to largest contentful paint. So largest contentful paint, for anybody who is not familiar, it's one of the new core web vitals. And what it's measuring is it's looking for the first moment when that largest piece of content gets painted onto the screen. It's meant to be representative of sort of that, when is it happening kind of indicator from a user perspective. So how quickly do I get something meaningful out on the screen? And they're using the size as a proxy. So the large is meant to sort of, there's a good chance that if it's the largest piece of content, it's also one of the most important pieces of content. When we look at the top 100,000 URLs today, what we see is that we're doing okay-ish on desktop. We're hitting in the top 100,000 URLs. We're hitting about 61% are hitting the good threshold, which is defined as anything less than 2.5 seconds. On mobile, we're not quite batting 50%, doing about 47% there, with the bulk of that coming in that needs improvement category. The thing with LCP is it turns out images and image performance is very, very closely intertwined with this metric. If you look at what counts as content for this metric perspective, they're looking at images, image elements that are tucked inside of SVG, poster images of video elements, background images, and then there's also text, like your block level text, like your paragraphs or headers or things like that. WebPageTest records what type of content is triggering the LCP element or event on any given test. Since HTTP Archive runs WebPageTest under the hood, that means we can query over millions and millions of URLs to see what are the most common triggers for those LCP events. And what we find is that it is dominantly image related. For both mobile and desktop, the primary form of the LCP event is the image element itself, or something like that. It's an image within the content. The next closest is background image, and then text makes up 27% of those events on mobile, 18% on desktop. So if you do the math and put it together, that means that 73% of the LCP events on mobile devices and 82% on desktop are either images in the content or background images. So in other words, when we're talking about optimizing for LCP, we are most often talking about optimizing your images and how quickly they load. And the thing is, we see a few very common issues, like, spend a lot of time looking at WebPageTest test results, looking inside of Chrome DevTools, just kind of nerding out on perf like, you're wont to do, the normal person does. And there's a few common themes for when those LCP events tend to be a little bit slow. And I wanted to walk through a few examples here. So first up, this is a PDP page for Bose. We recorded this on a Moto G4 over a 4G connection. And you can see this element here where we've got the film strip view. We've got the red box here with the green overlay on top of the image. That's indicating that that's when the LCP event fired. And that's what the LCP element in this case was this hero image. Pretty typical for e-com or really anything, is to have sort of that hero image that kind of triggers that LCP event. Now, if we look at the waterfall, the request that you see here highlighted in green, that's the one that is triggering this LCP event. In this case, it's request number 96. So it's very far down the food chain here in terms of when the browser is trying to parse and load this page. And if we look at the LCP events information that's being surfaced for this test, we get a little bit more information. We can see the size. We again see that time, that 26 seconds. We see the source because it was an image. And we collect a little bit of that outer HTML just so that it's a little easier for you to be able to find like what's going on. Where does that element reside inside of your HTML? Now, if you look at the outer HTML, there's one chunk of this that jumps out, and that's these attributes here. There's a lazy auto sizes and a lazy loaded attribute being applied inside of the HTML. Now, anytime you see this, this is a pretty solid indication that some sort of JavaScript library is responsible for lazy loading this image. Very common, lazy sizes is the most common form that we see for this. But those attributes are sort of a dead giveaway. And in fact, it turns out that this is pretty common. Again, querying the HTTP archive data, at least 14% of LCP images are lazy loaded. That could be, it's most frequently through the JavaScript method. There's also a native method, which we'll talk about in just a minute. But it's a pretty common issue. And so what happens when it's JavaScript involved is we see markup like this. This is the markup for that image. You can see we've got a class, we've got a data lazy, which is pointing towards the different source for the images. We have some source set, again, wrapped inside of a data attribute. We have alt, which is great. What's missing here is the source attribute. We have no source attribute. So when the browser is parsing this, it doesn't see the image, like it can't tell which image it's supposed to go off and request and load. And so as a result, we've got a bit of a bottleneck here. We have a delay. The browser first has to go through and execute all the JavaScript to figure out what that source is going to be. Then it can go off and make the request for the element or for the image. And so we see that back at this waterfall. You see that thick pink bar? That's all JavaScript execution related to DOM content loaded. Notice how we've got this big chunk of execution occurring at during that time period. And then it's shortly after is when we make the request for the image. That's because in here we have this sort of process where JavaScript is going through, figuring out which image size to load, and then injecting it into the HTML, at which point the browser now knows it exists and can go off and request it. And that's why we end up requesting it so late in this case. So if you're going to lazy load JavaScript, lazy load an image, the better alternative to do nowadays is to use the native method wherever it's available. And that's this loading attribute. What's nice about the loading attribute is we can have the source elements attribute sitting inside of our HTML. So the browser can parse the HTML right away. It has the markup generated. It doesn't need to wait for JavaScript to run or execute to be able to get at it. And then we can use this loading attribute to indicate like, hey, you should grab this right away, like we're saying here in the top with loading equals eager, or let's lazy load this, depending on where it falls within the viewport. And that's this loading equals lazy value. And again, we've removed the JavaScript bottleneck at this point, but it's still, we have to tread with a little bit of caution here. There was some great research done in conjunction with the Chrome team and the WordPress team around too much lazy loading. If you go back to the markup here, remember the hero image, we kind of had this loading equals eager, saying go ahead, aggressively grab this image. We know it's going to display. We want it out as early as possible. WordPress for a while was doing this thing where it was applying loading equals lazy to all images, even images within the viewport. And so what they found when they started digging in is that there was this great research done where they discovered that, like we have the loading attribute being used, and yet LCP events are firing slower on these pages. What gives? And so that's when they discovered that, yeah, even in the viewport, that lazy attribute was being applied. And that meant that the LCP element was being delayed just enough to actually slow down the actual event timing itself. They did work on a fix. And so what you see here is the results of sort of the default behavior and then going through and actually trying to apply this fix. And you can see they found an 18 to 14% reduction in their LCP times. And all they did here was not lazy load the hero image. If the viewport, don't add that lazy loading attribute to it. So you do have to tread with a little bit of caution. If you're using lazy loading via the attribute, make sure you're not applying that to your in-viewport images. Otherwise, you're going to push out that LCP event. Another common issue, this is another example. This is ethicaltraveler.org. Here we've got a film strip. Now theirs doesn't look as bad. This was a desktop browser, ran a little bit faster. Their site is actually pretty trim, neat, not a lot going on, so things load pretty quickly. But even here, we're seeing that LCP event was firing at around 2.9 something, so about 3 seconds here. And you can see it's that big masthead across the top. So that's a little bit over our threshold. That's in that needs improvement range. So let's look and see what we can figure out what's going on here. So if we look again at the waterfall and we see that the LCP image itself is being highlighted, it's request number 28. So it's a little bit down here. If you look above it, we've got this first chunk of requests from lines 2 to 17. Those are all render blocking CSS and JavaScript files in the head of the document. Then we've got sort of the stair step when Chrome gets out of the head and starts bringing in everything else. And that's where we have these other JavaScript files. But you can see even here, we've got a logo, we've got a mag glass icon on line 26. We've got a few other images competing here with this image from bandwidth. And it is being identified a little bit later than we'd like it to be. So if we look at the markup in the event summary again for this particular one, here we find out it's actually a background image. So this is not, again, just like with the JavaScript issue, this means that that image itself isn't in the markup. There's no source attribute, no image element for the browser to prioritize and grab that right away. With CSS, we have a bit of a delay here. It's not quite as bad as a JavaScript executed, at least, but we still have to go a little ways in the process before we can find this image and make the request. When the browser is loading a page, it's looking for that HTML, JavaScript, and CSS to create the document object model and the CSS object model. And once it has those two, it pairs them together to create the render tree. It's at this point where we have this render tree created. That's when we go out and we make the requests for those background images. So we've added a few steps here between the path from when the browser gets the HTML to when it discovers that image and it goes off and makes that request. So whenever you have an LCP element that ends up being a background image, you're going to have a little bit of a delay. And remember, if we go back to the data we saw before, this happens on about 27% of mobile sites and 31% of desktop. So for this one, what we need to do is we need to find a way to get that element or that image into the markup so the browser can find it earlier. Now, one alternative is if you can, and if it makes sense from a semantic perspective, you could move that image into an actual image element. But let's just say, for sake of this talk, that's not the case. Like maybe it is purely decorative, or for whatever reason, you're not able to get it inside the markup as far as an image element. That's where we're going to need to resort to hinting to the browser that this image exists and that we should get a head start on pulling it in. So the first thing you'd reach towards, or at least the first thing I would historically reach towards here, is the preload. We add this to our header. We say, hey, I'm going to preload this image. And this tells the browser that this is really important and please go request it right away. Or at least as early as you think it should be requested. I guess it gets slightly more complicated now due to a few fixes we'll talk about in a second. So if I do this, this tells the browser this is a high priority image. Now it doesn't have to go through the whole render tree process. It's going to request it. In fact, it's going to request it right away. I ran the same page through WebPageTest using Cloudflare workers as a proxy just to manipulate the HTML a little bit and inject the preload. And you can see in this case, now our LCP image is the second request. It's been pushed way up on the waterfall, and we end up with a much faster LCP as a result. So yay preload, right? This is where it gets a little bit more complicated and frankly, where we're all going to have to go back and revisit our understanding of preload and how this works and what impact it has on performance. So as of version 95 of Chrome, preload behaves differently. I think I saw Pat join in the room. We all have Pat to thank for this, and it is a good thing. Preload had some significant issues with the way that it worked that basically had this sort of jump the queue, jump the line behavior by default every time you were preloading something, which is not necessarily what you wanted. Preloading an image doesn't necessarily make it more important than, for example, actual CSS that we need to display the page, or JavaScript that may be blocking that we need to execute before the page can be displayed. It probably shouldn't jump the line over those, but preload historically has been a little bit of a blunt force like maneuver. That's what it does, is it jumps it right to the top. Pat did some work, made it do better work around prioritization, fixed some bugs there. And so now preload behaves very, very differently. So if I test this same experiment, and now I run it inside of Chrome 95, which is Chrome beta at the moment, and I compare my two runs, the top one here being with no preload, the bottom one here being with our preload, my LCP is pretty much identical between the two runs. Which is not what we would have expected. That's not what we get in the current version of Chrome, and it's not what we have come to learn preload means. And if we look at the waterfall for this preload inside of 95, we see the image bumps it a little bit. If you remember, it was online, it was request number 28 before, a little bit delayed. We get it a little higher up. We're now giving it a higher priority than these other images, for example, but we're not anywhere near that second request. We're not jumping up into that earlier stage here because the new behavior is being implemented and applied. So what do we do here? Because preload doesn't actually fix this for us in this case. Well, now we have another thing that, again, Pat added, he's been on a roll, which is priority hints. This is the ability to, there was an experiment or an attempt at getting priority hints in the past, and that kind of failed, but now we're getting another go at this. And the idea here is to be able to signal to the browser the relative importance of a particular asset. So if we go to our preload, you'll notice this one last line change, and this is me saying importance is high. So what I'm doing here is I'm indicating to the browser that, okay, yes, there's an element, there's an image resource that I'd like you to preload. Now, normally you're going to preload that at a low priority because that's the priority rank of images. But in this case, I'm going to override it. And I'm saying, I want this to take a high priority. I want this is important to me. It's the hero, and I want it down as early as you can. With this hint back applied, and then testing in Chrome 96, where this exists now, now suddenly when I'm doing my comparison, I can see that the preloaded version gets the LCP element out much earlier than the no preload version. And if I look at the waterfall, you'll see I don't jump all the way to number 2, but I do jump to that 17th request. So now we've signaled that it's a high priority thing, but the browser is still factoring in the relative priority of this render blocking CSS and JavaScript that we have on the page. So it's not jumping all the way to the top, but it is pushing it up higher into that discovery process and making sure that we download and request it a lot earlier. Priority hints are very, very early in experimentation, but Pat has been posting all sorts of examples on Twitter. You know, an example where Amazon took the LCP down from 3.6 seconds to 2.8 seconds by adding an importance high to the hero image. Airbnb, during Pat's experimentation, saw 600 millisecond improvement by doing basically the same thing. This is very, very early days on this, so the more experimentation, the better. There is an origin trial available. Probably the easier way for you to play with this now, though, is to fire up Chrome 96 with a command line passing in the parameter of enable blink features priority hints. If you do this, you can apply this CLI, for example, right inside of WebPageTest, or just kind of run it locally. But then you can test and sort of see what the impact is of these priority hints. And we've talked about it in the context of hero images here and preloads as well. But keep in mind, this could influence the priority of anything from asynchronous CSS to deferred JavaScript, you know, anything that you want to kind of play with. There's the sky is the limit here in terms of what we have for experimentation. So I do encourage you to play around with that, though, because the early returns on this particular one are very promising. And the other thing I want to point out when it comes to LCP and images is just making sure that it's measuring the right thing, because there are still situations where LCP doesn't quite get it right. And there's certainly situations where folks have been known to game things. There was an example that Punit posted a couple weeks ago, talking about a WordPress plugin that reduced the LCP from 2.08 seconds to 0.8 seconds without actually improving the time the hero image loaded, which sounds like magic. But if you look at the film strip, he kind of boiled down the experiment to like a reduced example. And you can see it in action here. On the top bar, we have the LCP event firing at 2.5 seconds and appropriately on the hero image. And on the bottom one, we have it firing at about 1.0 seconds with no image yet displayed. So what gives here is actually a pretty clever little workaround. If you look at the markup, that is a really slow transition. If you look at the markup here, what you'll find is that we have an image element. We have a data source, which points to the actual image that we want to display. And then there's a source attribute that points to basically just a tiny little inline SVG. We have height and width applied, so the browser fills up the appropriate space. And because it's this inline little bit of SVG, we get that display right away. So we're getting a very quick situation where the image size gets painted out on the screen, things look great. And then later on DOM content loaded, we swap the source and the data source here. And now we get that hero image in place. I just want to make it very, very clear. I'm not saying do this. This is gaming helps no one. And I'm pretty sure the browsers are going to figure out how to kind of counteract a lot of these sorts of situations anyway. But the point here is that, make sure that when you're actually measuring LCP, it's actually tracking something that is important to your users, and that it's tracking the right thing, and that you're not trying to manipulate the results. Like at the end of the day, we have to remember why we're doing it. Performance is a fundamental component of the user experience, and we don't make things faster for the sake of making things faster. We make things faster because we believe that that is going to have a better outcome for the business and a better outcome for the users. And when it comes to LCP, that means putting a lot of effort and energy into making sure that you're serving lightweight images and that they're getting down as fast as possible. Thank you.